Solving absolute value functions algebraically. So first we're going to start with linear. The first thing you need to do is you need to put it into piecewise function notation. So we have our positives and our negatives, and we want to find the positive and negative values of the absolute values. So 4x plus 6 is greater than or equal to 0, or 4x plus 6 is less than 0. So x is going to be greater than or equal to 6 over 4, which is negative 6 over 4, which is negative 3 over 2, or x is less than negative 3 over 2. So our piecewise notation would be y is equal to 4x plus 6 if x is greater than or equal to negative 3 over 2, or negative 4x minus 6 if x is less than negative 3 over 2. So here's our piecewise notation. Now we are going to solve both for the positive and the negative. So we have x plus 8 is equal to the positive 4x plus 6, or x plus 8 is equal to the negative 4x minus 6. So if we solve this, we minus x from both sides, minus a 6 from both sides, and we get 2 is equal to 3x, divide by 3, divide by 3. So 2 over 3 is equal to x. Next, we're going to check to see if it is extraneous. If it is extraneous, it won't meet these conditions. So 2 over 3 is greater than or equal to negative 3 over 2. Because this is true, we know that this is a real root. For this one, we're going to add 5x and subtract 8. So we get 4x, just kidding. It equals 5x is equal to 14. Divide by 5, and x is equal to 14 over 5. Now we check to see if this is in our conditions. This is, of course, a negative. So negative 14 over 5 is less than negative 3 over 2. This is true, so this root also works. So our two answers are x equals 2/3 and x equals negative 14 over 5. For the quadratic, we're going to do the same thing. We're going to split it into two groups. We either have the positive of the function, which is the original, or we have the negative of the function, negative 3x minus 2 squared plus 4. So let's solve the positive first. So we're going to subtract 4 from both sides. So we have 0 is equal to negative 3 times x minus 2 squared. This cancels. That means that x has to equal positive 2, because it's already factored, and we know that x has to equal 2. So this is one solution, x equals 2. We can verify this by plugging it into our calculator. So if you go 4 is equal to the absolute value of negative 3 times 2 minus 2 squared plus 4. This cancels, so we have 4 is equal to the absolute value of 4, which is correct. Now for this one, it's a little bit more work. So we have 4 is equal to, distribute in the negative, 3x minus 2 squared minus 4. Nothing cancels itself out, so we're going to have to expand and simplify. So we have 3 times x squared minus 4x minus 4. Do not forget to FOIL out and distribute everything in the brackets for the x minus 2. Subtract 8, distribute the 3 in, so we have 3x squared minus 12x minus 12 minus 8 is equal to 0. So 0 is equal to 3x squared, and this is a positive, just kidding, minus 12x plus 4. Now this isn't going to factor, and so you're probably going to have to use the quadratic equation a lot, so don't forget it. So x will be equal to negative b, so negative 12 is a positive 12, plus or minus the square root of a b squared, minus 4 times a times c, all over 2a, 2 times 3. And if you simplify this, you should get 12 plus root 96 over 6, and 12 minus root 96 over 6. So there's two possible equations. You can simplify them. They will in the textbook. I'm not too concerned about simplifying. I know that you know how to do it. But you should verify your answers. So if you type all of this in and put it into your original equation, you should get a 4, and the same with this one. So always verify your answers. Sometimes there are extraneous roots.